Hi everyone. Today we're going to start on 1.6, which is the last section in chapter 1. So it should be relatively short, so I'm hoping that we can finish it in one video. All right, so let's get started. So 1.6 talk about something called cross product. So what is a cross product? So let's start with the following. A cross product is defined only for vectors in R3. And what does it do is this: the cross product of two vectors in R3. So first of all, when you see this, that means, okay, number one, the two vectors have to be in R3. And because you're using two vectors, it identified to be a binary operation. So you basically combine two vectors into something else. So the cross product between of two vectors in R3 is actually a vector in R3. So this is very unique because the only other product that we know that allow us to combine vectors together is dot product. But yet dot product actually does not return a vectors, but rather return a scalar. Cross product, on the other hand, allow us to combine two vectors in R3 and yet return a vector in R3. Okay, but there's something special about this vector. So it's a vector in R3 that is perpendicular to both given vectors. So meaning the following. So go and let's define. Let's do a definition. So let's say given two vectors in R3. Let's say vector u, which is u1, u2, u3. And let's say vector v, which is v1, v2, v3. The cross product of u and v is what we call u cross v. Okay, so that's what it is, u cross v. And what's special about u cross v is the following. U cross v is perpendicular to both vector u and vector v. So that's the significance of this vector u cross v, which is actually perpendicular to two separate vectors. Now, then how do you calculate u cross v? So u cross v is actually given by the following formula. U cross v is given by the formula u cross v is equal to, because u cross v is a vector in R3, I'm actually defining three separate formulas. The formula is u2v3 minus, v2u3. The middle one is u3v1 minus v3u1. The last formula is u1v2 minus v1u2. So that's the formula that generates a cross product. Now, it's similar complicated formula, but it's definitely something that you can memorize. I'll show you how to use the formula. So let's start with a very basic example. How about this one? Let's say we're going to let vector u equal to 1, 2, negative 1, and vector v equal to 3, 0, 2. And I'm going to just simply ask you to find u cross v. So how do we go and then do that? Well, simple. The easiest way is simply use the formula. So I'm just identify this is my u1, this is my u2, this is my u3. This is my v1, this is my v2, this is my v3. So now I'm going to go ahead and find u cross v using the formula. U cross v would equal to, let's see, u2, which is 2, multiplied by v3, which is also 2, minus v2, which is 0, times u3, which is negative 1. All right, the middle one is u3, which is negative 1, multiply v1, which is 3, minus v3, which is 2, multiplied by u1, which is 1. The last one is u1, which is 1, multiplied by v2, which is 0, minus v1, which is 3, multiplied by u2, which is 2. So now it's just a matter of plugging those calculate those numbers and find out what it is. So it's 4 minus 0, which is 4. And then negative 3 minus 2 become negative 5. Oh, not yet. And the last one would be 0 minus 6, which is negative 6. So this is the vector u cross v. Now, of course, the big question, what's the significance about this vector 4, negative 5, negative 6? So the idea of cross product is that this vector that we have, it should be perpendicular to both u and v at the same time. And that's a very unique vector that will do that. Okay, u cross v is the only direction vector that will actually be perpendicular to both u and v, other than obviously multiple of itself, because that will point in the same direction. So this direction u cross v is the unique direction that's perpendicular to both u and v. Now let's try to see if that's the case. How do I know two vectors are perpendicular to each other? Well, simple. We do the dot product. So let's see if I take u, which is 1, 2, negative 1, and dot product 4, negative 5, negative 6, what do I get? Well, let's see. That would equal to 4 minus 10 plus 6. Voila, which is 0. What if I take 3, 0, 2 and dot product 4, negative 5, negative 6? What do I get? Well, let's see. That would equal to 12 plus 0 minus 12, which is also 0. There you go. So therefore, it shows that 4, negative 5, negative 6 is perpendicular to 1, 2, negative 1, as well as 3, 0, 2. Now, some of you might find the cross product difficult to difficult to memorize. And some of you actually might learn how to find cross product in maybe in physics, which show you some slightly different methods. So we can definitely try that too. So let's say I have vector u, which is negative 1, 1, 5. And let's say vector v is equal to 4, negative 1. Let's try to find u cross v. So one way to do this is to, instead of memorize the formula, it's kind of memorize the method to find it. There's a reason why it's called cross product, because we are actually kind of forming cross. So show you. So suppose I have vector u. I'm going to put down negative 1, 1, 5. And I have vector v, which I'm going to have is 2, 4, negative 1. Okay? So show you how to calculate this cross product. So the first number, so let's see, I'm going to try to do u cross v equal to. Okay? So show you how that works. So first number is actually right here. The first number is formed by this cross right here, where you take this these two numbers, and then subtract the product of these two numbers. So therefore, the first set of number would be 1 times negative 1 minus 4 times 5. Then what you're going to do is the following. To do the next set of numbers, what you're going to do is we're going to take these two numbers and move it to here. And then form another cross. Same exact concept. Will be these two numbers multiplied together minus these two numbers multiplied together. So therefore, this would be 5 times 2 minus negative 1 times negative 1. Now, what happened to the last number? Then you take this one and move it to the end, and then form another cross. Remember, it's called cross product because that's what we try to do. We try to form cross. So therefore, this will be negative 1 times 4 minus 1 times 2. And now it's just a matter of calculating numbers. So therefore this would equal to 1 times negative 1 is negative 1, minus 4 times 5 is 20, so it becomes negative 21. 5 times 2 is 10, 10 minus negative 1 times negative 1 is 10 minus 1, which is 9. Negative 1 times 4 is negative 4, minus 2 is negative 6. Okay, so this is more a visual way to identify how to do the cross product, and I actually use that method because it's easier to remember, but it does take a long time to kind of write it out. But it's not hard to memorize the cross product because you're basically just using cross. And the key is to remember is that you would first cross is actually using the second and the second set and third set of numbers, and then you just keep moving the number in front to the back to form more cross until you form 3 crosses. Now that we talk about cross product, the next thing I want to show you would be properties of cross product. So because of the way that the cross product is defined, there are certain properties that allow us to simplify when we're doing math problem with cross product. Oops. Sorry. So next thing I want to show you is properties of cross products. So let's say we are given vector u, vector v, and vector w in R3, and let's say we have some kind of scalar. Oops. Let's say R. So there are many different properties for cross product, but I just only want to show you these 3 cross product properties. Number 1, what if I take vector u cross vector v, and if I reverse the order of the cross product, what happened? If I reverse the order of the cross product, you actually get the opposite perpendicular vector. Okay, so therefore cross product is not commutative, it's anti-commutative, meaning they actually form the opposite of the cross product when you reverse the order. Number 2 is, can I distribute cross product into a sum of 2 vectors? Meaning if I do u cross v plus w, what do I do? Well, as a matter of fact, cross product actually does work with distribution. You can actually distribute vector u in a cross product into u v plus w by doing 2 separate cross products. Now, however, important to understand is that you have to maintain the order of which you multiply the cross product, because cross product is not commutative. Now, the last property is usually the one that gets students all confused. The last property is this one. What if you have a scalar and then you want to multiply into a cross product? What would happen? Well, here's where students get confused and students try to do a distributive property. But no, remember what I told you, distributive property is only for a multiplication into an addition. Here we don't have that. Cross product is very similar to multiplication instead. So therefore, in this case here, it's more like you multiply 3 things together than to multiply into addition. So therefore, this property is actually more associative property than distributive property. So what happened when I multiply R into a cross product between 2 vectors, u and v? You can either multiply u by R, then cross with v, or you can multiply v by R, then cross with u. You do not have 2 separate u. You don't distribute and give u to both u and v. In here is more about organizing which way you multiply. You either multiply R with u first, or R with v first, then cross product, or you can do the cross product, then multiply by v, by R. Okay? Now, what is probably one of the most important usage for cross product? Well, if cross product allow us to find the perpendicular vector, then it's perfect for us to do this right here. This is a problem right here. Imagine the following. Let's say given a plane in parametric representation. Let's say vector x is equal to t1, 4, negative 1, 2, plus t2, negative 1, 3, 5, plus 1, 7, negative 2. And what I'm going to do is rewrite it in standard form. Now we learned about standard form of a plane in 1.5, and we know that we need a perpendicular vector to do that. The problem is that I always give you the perpendicular vector because you really don't have other way to figure it out what the perpendicular vector is. But now with cross product, it's a little different now. If I want to write this in standard form, what I need to do is first identify the perpendicular vector. And guess what? The perpendicular vector can now be formed by forming the cross product between the two direction vector. So we'll repeat. When you're given a plane in parametric form, you can form the cross product of the two direction vector, and that will give you the perpendicular vector that you need for your plane. So here I'm going to do the cross product between 4, negative 1, 2, and negative 1, 3, 5. So what would the cross product be? So you can definitely just use the formula, or I'm going to do is I'm going to just do the cross method right here. So first cross is this one. And the second one is this one. And the third one is this one. So what would my cross product be? So it will be negative 1 times 5, which is negative 5, minus 2 times 3, which is 6. So negative 5 minus 6 is negative 11. 2 times negative 1 is negative 2, minus 4 times 5 is 20, so become negative 22. 4 times 3 is 12. 12 minus negative 1 times negative 1 is 1. So 12 minus 1 is 11. Notice that this actually have a common factor of 11. Or actually, I'm going to pull out negative 11. So become 1, 2, negative 1. So I could definitely use negative 11 times 1, 2, negative 1 as my perpendicular vector. But I mean, I don't see why I need the negative 11. So I'm just going to say, in this case, I'm going to let P be 1, 2, negative 1. Now, if you do want to use negative 11, negative 22, 11, you are perfectly okay, but you realize that once you multiply that by the points, you will have a constant that has a 11 as a vector that you want to divide out. So you might as well divide it out right now if you can. But if you don't believe me, you can definitely use negative 11, negative 22, 11 as your perpendicular vector, and then you can see for yourself what happened. And you get the same answer as I do. So here's my perpendicular vector. So what I'm going to do is identify x sub 0. So x sub 0 will just be a point on the line, which we already know one right there from the parametric representation. So now I'm going to just write out my equation. My equation will be 1x plus 2y minus 1z equal to 1, 2, negative 1, dot product 1, 7, negative 2. So my plane would be x plus 2y minus z equal to, and then if I do this correctly, it will be 1 plus 14, so 15, 15 plus 2, which is 17. Here you go. All right, that's not too bad. So now what I'm going to ask you to do is, what if now I have a second plane? So let's say I'm going to say, given a plane P. So this is plane P. Now what if I have a second plane, which is plane Q? Let's say we're going to be given another plane, which I'm going to call Q, with parametric representation. vector x equal to, I don't know, t1, 1, 3, 2, negative 2, plus t2, 5, negative 1, 1, plus 7, 2, 0. And I'm going to ask you to do the exact same thing. Let's see if we can do this. I'm going to ask you to rewrite in standard form. All right, so you can definitely pause the video to try it out on your own. I'm just going to quickly do this. Okay, so the perpendicular vector in this case would be the cross product between 1, 3, negative 2 with 5, negative 1, 1. So what would that equal to? So once again, I'm going to do the exact same thing. I'm going to do 1, 3, negative 2, 5, negative 1, 1. So my first cross is this one, which is 1 times 3 minus negative 1 times negative 2. So it would be 3 minus 2, which is 1. We'll put 1 and 5 at the end, and then we'll do a cross. So negative 2 times 5 is negative 10, minus 1 is negative 11. Okay. And then I'm going to move the 3 and negative 1, and then I'm going to go and do the same thing. So that will be negative 1 minus 15, so it's negative 16. There's no common factor here, so I'm going to just leave it the way it is. So therefore, I'm going to go and let my vector P to be equal to 1, negative 11, negative 16. We already have vector x of 0, which is 7, 2, 0. So now I can just say is x minus 11y minus 16z equal to 1, negative 11, negative 16, dot product 7, 2, 0. So if I do my math correct, that will be x minus 11y minus 16z equal to, look like 7 minus 22, so negative 15. And that would be this plane right here. Now, here's something interesting. What if now I want to also figure out the following? How about if I have this question? Is plane P and Q parallel? How would I know? Now, if you remember what I told you last week, on one of the videos, I told on one during class actually. I don't think I mentioned on the video, but I think we talked about during class. I told you that you cannot determine if two planes are parallel by looking at the direction vectors, because there are way too many different pair of direction vectors that can be used, and there is no direct correlation between the direction vector, meaning that two planes can be parallel. It is possible for two planes to be parallel without any of the direction vector being multiple of each other. So what is the better way to determine if they are parallel or not? Is by looking at the perpendicular vector. So in this case, you can see that P has its perpendicular vector. What is that? 1, 2, negative 1? 1, 2, negative 1. And Q has its perpendicular vector. 1, negative 11, negative 16. So now I can tell you that P and Q are not parallel. How do I know they're not parallel? Because 1, 2, negative 1 does not equal to some constant times 1, negative 11, negative 16. So that's how I know. You look at the perpendicular vector. Very simple. Now what if I also want to find out, are they perpendicular? Now that I know they're not parallel, that means in R3, two planes that do not parallel must be perpendicular, must intercept each other. So therefore I know that these two planes, plane P and plane Q, must intercept. Now we're not going to talk about the intersection in this case yet, because that will be what we're going to talk about in chapter 2. But I do want to find out if they do intercept, can they possibly be perpendicular? Is plane P and Q perpendicular? Well, then how do I figure it out? So if you recall from last video, two planes, or actually 2 videos ago, two planes are perpendicular if their perpendicular vector dot product is 0. So let's find out. So what is the dot product between these two planes? Well, that looked like 1 minus 22 plus 16. And that come out to be 5 or negative 5, which is not 0. So therefore I can say no, P and Q are not perpendicular to each other. Notice that when it comes to planes, you actually do use your perpendicular vector to compare them to determine whether they're parallel or perpendicular. And therefore require you to find the perpendicular vector if you are given in parametric form. And to find that perpendicular vector, what you do is you do cross products. That is a very important concept that you will be tested on multiple times on your next test. So be very careful. Now, before we move on to the last topic, then I do want to talk about this then. What if you are given 3 points? How would you go about finding the equation of the plane? So let's say I ask you for this. Write the standard form of a plane that contains these 3 points, 2, 1, 3, negative 1, negative 2, 4, and 3, 3, 2. So how do you write the standard form of a plane? Now you already know how to write the parametric representation of a plane with 3 points. So how do you form the standard form? Well, the first thing you're going to have to do is the following, and I'm going to tell you this right now. You will be asked a problem just like this on your next test. And yes, the question will specify I want the standard form of a plane. And if you give me the parametric representation of the plane, you will only get half credit at best. Okay, because you didn't follow the direction. You didn't do what the question asked you to do. So how do I form the standard form of plane? So first thing you need to do is to form the perpendicular vector. But you won't be able to find the perpendicular vector until you find 2 direction vector that are on the plane first. So how do you find these 2 direction vectors? Simple. You find direction vector by subtracting. So I'm going to go and subtract. I'm going to say 2, 1, 3 minus negative 1, negative 2, 4. I'm going to also take 2, 1, 3 minus the vector 3, 3, 2. Now, do you have to subtract the way that I do it? No, you just have to subtract any 2 of the 3 vectors given here to form the direction vector. Okay, so here I'm going to just do this 2. So therefore I have 2 minus negative 1, which is 3. 1 minus negative 2 is also 3. 3 minus 4 is negative 1. So look like what I have is 3, 3, negative 1. Now 2 minus 3 is negative 1. 1 minus 3 is negative 2. And then 3 minus 2 is 1. So there you go. Now I have my 2 direction vectors. So now I'm on to my next thing, perpendicular vector. What would be my perpendicular vector? My perpendicular would be the cross products between these 2 things. So once again, I'm going to just do it this way. Okay. And so my first cross products would be this. So therefore 3 times 1 minus 2, which is 1. My next cross product, negative 1 times negative 1 is 1. 1 minus 3 is negative 2. My final cross product, let's see, 3 times negative 2 is negative 6. Negative 6 plus 3 is 3. So it seems to me that my cross product here is 1, negative 2, 3. So now I can go ahead and form my plane. My plane would be x minus 2y plus 3z equal to, I need the dot product between the perpendicular vector at any one point on the plane. But I do have 3 points, so I'm going to just pick any one of them. I'm going to just do 1, negative 2, 3, dot product, 2, 1, 3. So that would be 2 minus 2 plus 9, so there will be 9. So my plane is x minus 2y plus 3z equal to 9. Actually I make a mistake right here. 3 times negative 2, this number is actually negative 3, because 3 times negative 2, actually no, it's not even negative 3, it is negative 3, my mistake, negative 3. Okay, you know what, let me fix this. Negative 3, because it's 3 times negative 2, which is negative 6. Negative 6 minus negative 3, which is negative 6 plus 3, which is negative 3. So my mistake. Let me just fix this right here. And we'll put negative, and that will change this number right here. So that number actually become negative 9. So therefore equal negative 9. There you go. All right, now I do have one more thing I want to show you. So that will be the last thing I want to show you, and that would be it for this video. I know it's past 30 minutes already, but instead of giving another video, just want to finish this up. So the last thing I want to show you is this, is the area of a parallelogram in R3. So it is interesting that cross product actually allows us to actually calculate area of a parallelogram in R3. And this is how. Let's say given two vectors in R3, let's say vector u and vector v, and let's say we let vector u and vector v be two adjacent sides of a parallelogram. Meaning the following: if I take vector u and vector v, I'm going to be able to form this parallelogram right here. Where u and v are the two sides, and then you can basically just translate v to the end of u and translate u to the end of v, and therefore you form a parallelogram. The interesting thing about it is that this area, the area of this parallelogram, is actually given by this expression. Oops, it's given by. Is given by this formula. The area of this parallelogram is actually equal to the length of the vector u cross v. So very interesting that the length, the magnitude of the cross product not only represent the length of the perpendicular vector, but also somehow equal to the area of the parallelogram. Give you a very simple example. Let's say we let vector u equal to 4, 3, 2, and let's say vector v is equal to 1, 0, negative 1. We go find the area of the parallelogram formed by using u and v as two adjacent sides. Okay, you cannot use them at opposite side, because if you use them at opposite side, you won't form a parallelogram unless u and v are the same direction. Then you won't have the other two sides, so that would not work. So have to be two adjacent sides. So we can definitely do the cross products. So that just equal to 4, 3, 2 cross product 1, 0, -1. Now we have done quite a few of these cross product already, so I'm going to trust that you can do that on your own. So I'm just going to show you what the answer is. So that come out to be -3, 6, -3. And so now what is the length of these cross products? Well, that would be what the area is. So the area equal to the length of the cross product, which is the length of this vector, which is square root of 9 plus 36 plus 9. So seem to me come out to be square root of 54, or 3 radical 6. And no, I don't want it in decimal form. I would rather have it in radical form. All right, unfortunately, that's it for today. That actually concludes section 1.6 as well as the entire chapter 1. All right, talk to you guys later. Bye-bye.